Please title these notes Applications 1 Notes, Position, Velocity, Acceleration, and write today's date. By the end of this lesson, you should be able to use the sign charts, the little lines, and this table here to solve problems with position, velocity, and acceleration. The basic scenario is that something's moving back and forth along a straight line. So, for example, the little moving man demonstration that we've worked with, where he's moving just back and forth basically along an x-axis. What we're doing is we're imagining that there's a moving man or a squirrel walking on a wire or a bug walking on a wire or just a particle moving along the x-axis that's moving back and forth. And what we're trying to figure out is what can we determine about its position, its velocity, and its acceleration. So the key thing to know about this is that these problems are the same as f prime, and f double prime problems. F corresponds to position, f prime to velocity, and f double prime to acceleration. So what that means is it means that if I start off with position with respect to time, incidentally, P of t, for whatever reason, is not very commonly used. This is also written as S of t, don't know why, or x of t. All those are position. The derivative of position is going to be velocity with respect to time, so that's velocity. The derivative of velocity is acceleration. And then going back up the other way, the antiderivative of acceleration is velocity. The antiderivative of velocity is position. So position, take the derivative, you get velocity, take the derivative, you get acceleration. Acceleration, take the antiderivative, you get velocity, antiderivative, you get position. Same idea as with f. Derivative is f prime, derivative of that is f double prime. To solve these problems, use sign charts, that's these, just like you did for f, f prime, and f double prime. First though, you need to know what the problem is asking for. Right here is a chart of all the different words that mean different things in terms of mathematics. So, for example, if we're talking about when a particle is traveling to the left, that means the velocity is negative, traveling to the right means the velocity is positive, and so on and so forth. This is incredibly, incredibly critically important to memorize. Absolutely, absolutely, absolutely must be understood and memorized. Sleep with it under your pillow, or you'll be eaten by a dragon. Make sure you have it down. Should also be aware, right at the end of this, for all real-world problems, time is always going to be greater than or equal to 0. We don't have such a thing as negative time, typically. So take a second, pause the video, write down all the different meanings of the words in terms of mathematics. Write down that little piece at the end, and then restart the video when you've gotten that all written down. We'll talk about where it comes from. Here's moving man. Notice that as he's moving to the right, velocity is positive. When he gets to his furthest point to the right, this is right where velocity changes from positive to negative. And then as he's traveling to the left, we're going to see right here, velocity is negative. Notice there was a moment right when velocity was 0, when he was at rest. Let's go back. So right there, right for that moment, right when he changed direction, velocity was 0. He was at rest for just a second. Now he's headed back to the left. Notice also that the furthest to the right that he ever got, that was right there at that maximum value for position. And the furthest to the left that he's going to get is going to be right over here at the minimum of position. Right there. One problem that's always tricky is figuring out what's his greatest distance from the origin. Notice how when he was over here, he's heading away from the origin right about at 8 meters. That's as far as he got in this direction. But as he heads over to the other direction, when he reaches that minimum, little bit past, like maybe 8.5 meters, and then comes back the other direction. So when we're looking at the greatest distance from the origin, what we're looking at is going both in the positive and in the negative direction. What's the furthest away that he got? Positive 8, negative 8.5 or so. So that's what it means with this, where we're talking about find the minimum and the maximum position. Take the absolute value and see which is largest. We don't care if he was in the negative or the positive direction. We just care how far away he got from that original point. There's one other that can be pretty tricky to remember, and that's about speed. So remember, speed is the absolute value of velocity. We don't care what direction we're going. But the key thing to be aware of is that when a velocity and acceleration have the same sign, so they're both positive, like right now. Notice they're both in the same direction. He's speeding up. As soon as they switch to be in the opposite direction, he's slowing down again. Now, even though they're both negative, they both have the same sign, he's speeding up in the negative direction. Then when they switch, or opposite, he starts slowing back down again. Right like that. So if you have any questions about where the chart comes from, Google Moving Man, play around with this little app for a bit, and verify for yourself why those words translate into that math. Let's go and do some practice problems with this. So go ahead and write this problem down. The position of a particle traveling along a straight line is given by s of t, I don't know why they use s, it's frequently used for position, equals 2t to the third minus 9t squared plus 12t minus 4. And our first question is, when does the particle change direction? Now I'm going to write my translation in terms of changes direction. What does that mean? That means velocity changes sign. I'm going to write this right here. When does velocity change sign? Well, sign, that's positive or negative. So that means that I need a chart for velocity. And it's going to be the positive negative chart. So I have position right now. And the thing that I have to remember is that to get velocity, I just have to take the derivative. Just like if I had f, I would take the derivative to get f prime. So if s of t, position, is 2t cubed minus 9t squared plus 12t minus 4. V of t, I just bring down that exponent. And now, once I have this and this, I can figure out where this is positive and negative. So V of t, I can factor that. positive 1. Now remember, our t is always going to be greater than or equal to 0, so I'm just going to stop right there at 0. And now I can look here and I can see already I've got 3 different factors here. This is always positive. This is negative until we get to 2, then it's positive. This is negative until we get to 1, then it's positive. So, when does velocity change sign? At 1 and 2. We have a switch from positive to negative and a negative to positive. And there we go. Similarly, when is the particle traveling to the left? Well, I look it back up on the table that I just wrote down. Traveling to the left means velocity is negative. Looking right up here, I said just made my velocity chart. Velocity is negative between 1 and 2. We can also be asked questions like this. When does the maximum acceleration occur on the interval (0, 5), and what is its value? Well, if I'm going to have maximum and acceleration, that means that I'm going to need to have an acceleration, and maximum comes from increasing, decreasing, so I'm looking for when A switches from increasing to decreasing. Now, since I'm working with equations, I need to have not increasing, decreasing for my equation, but where it's positive or negative. So I need something that's positive or negative that corresponds to when acceleration is increasing or decreasing. So I know that I've got this general pattern that if I have something that's increasing or decreasing, that means its derivative is positive or negative. So we don't really have a name for the derivative of acceleration. But what I want to do is I want to find the acceleration, I want to take the derivative of acceleration, and where that's positive or negative, that's going to tell me when acceleration is increasing or decreasing. Just like f is increasing or decreasing when f prime is positive or negative. So we know that velocity we had from the previous problem. And we've learned that acceleration is the derivative of velocity, so let's take the derivative of this. And that's not enough to tell me when acceleration is increasing, decreasing. I need to take the derivative one more time. And that's going to tell me when this is positive or negative. Turns out it's always positive, it's always 12. So that means on the interval 0 to 5, acceleration is always increasing. That means the maximum has to occur over here because it's always increasing. So the maximum acceleration occurs at t equals 5, and we want to find out what the value of the acceleration is. So we just say when t equals 5, what's a? Twelve times 5. 12 times 5 minus 18 is going to give us 42. These should have units on them. Let's go back and say that for this problem, position is in meters, time is in seconds. So acceleration, just like in physics, meters per second squared. How about another one? This is still the same problem. When is the speed of the particle increasing? Remember, we need to translate this into mathematics. So speed is increasing when velocity and acceleration have the same sign. Positive or negative. So looking back at the problems that we just did, I see I've got an equation for V, I've got an equation for A. So V of t is 6, t minus 2, t minus 1. And we did this one already. Positive, negative, positive. A of t, we said that was 12t minus 18. We haven't done a sign chart for that one yet, but we can do so quickly. Add 3 to both sides, divide by 2, 3/2 or 1.5. So that means that for acceleration, when t is less than 1.5, acceleration is negative. When it's greater than 1.5, acceleration is positive. So if I took a number like, let's say 0 or 1, and I put it in up here, 2 times 1 minus 3 is negative, times 6 is negative, so that whole thing's negative. If I took a number like 10, 10 times 2 is 20 minus 3 is positive, the whole thing's positive. So now what I'm going to do is I'm just going to compare these two. So let's go ahead and bring this down. And what I see is I'm looking for where they have the same sign. So here, from 0 to 1, velocity is positive, acceleration is negative. From 1 to 1.5, they're both negative. From 1.5 to 2, this one's positive, this one's negative. From 2 on, they're both positive. So what I see at these little parts that I circled in green is that these are both negative, both positive. So speed is increasing when t is between 1 and 1.5, or when t is greater than 2, because velocity and acceleration have the same sign. Notice that this is a very different problem than if we asked, when is velocity increasing? This is just a straightforward one. Velocity increasing to decreasing, starting at 0. So we don't know about increasing, decreasing directly. We need to find something that's positive or negative. The derivative of velocity is acceleration, so we need to find when acceleration is positive or negative. That we did right up here. We would say velocity is increasing when t, is greater than 1.5 because acceleration is positive. Another type of problem asks, what is the greatest distance between the particle and its origin on the interval from 0 to 5. What this means, if we look back at our original chart, is it means find the minimum and maximum of position take the absolute value take the larger. So after we take the absolute value, we're going to look for which one's larger. So these are our sign charts just like before. We want position. Minimum maximum comes from the increasing decreasing line. So because we have an equation, we can't just work directly with increasing decreasing. We have to look for where something is positive or negative. The derivative of position is velocity. When position is increasing decreasing, velocity will be positive or negative, just like when f is increasing decreasing, f prime is positive and negative. If we look back on our previous pages, we already have the equation for velocity, in fact the whole sign chart for velocity. And so that tells us increasing, decreasing, increasing, and let's see, we ended at 5. So unfortunately this doesn't actually narrow it down a whole lot. We could have a minimum here, we could have a minimum here, we could have a maximum here, we could have a maximum here. So we're actually going to have to check all 4 of them. Find the position at 0, at 1, at 2, and at 5. Figure out which one has the largest absolute value. So let's compare them. And we're going to compare the absolute value. And in this case, our original problem had given us the equation for position. So I'm just going to go back here. I'm going to get that. Position equals 2t cubed minus 9t squared plus 12t minus 4. And so that's what I'm going to use to plug in here. I'm going to say what's the absolute value of 2, 0 squared, cubed, minus 9, 0 squared plus 12 times 0 minus 4. And when I put that all in, I get that this is the absolute value of negative 4, or 4. Then I can go and do the exact same thing for the rest of it. 2 times 1 cubed minus 9 times 1 squared plus 12 times 1 minus 4. Do all that out, we get 1. Okay, once we've taken all that absolute values, clearly this is the largest. The greatest distance between the particle and the origin is 81 meters. We can also have problems that involve graphs, so let's move on to our second problem here. Let's say that we have the position of a particle that is moving on a line is at right. So you can just sketch that in, position and time. We're going to be told in the problem there's an inflection point right here. This is at x equals 4, horizontal tangent line at x equals 6, and another horizontal tangent line at x equals 2. And we've got a couple of questions. The first question, for what values of t is the velocity of t positive? One of the things that we have to remember is that here we've got v, we want to know where it's positive, negative, but what we're given is position, and position is the antiderivative. This is different than the ones that we did in the graph analysis unit where we were always going down. So if a function is positive or negative, that means that its antiderivative is increasing, decreasing. So here I can see that p is increasing from 0 to 2. It's decreasing from 2 to 6. And then it's increasing again after that. So that means that increasing here translates down into positive, then negative, then positive. Let's see, this should have a little arrow saying it goes off forever. So v of t is positive when t is between 0 and 2, or t is greater than 6, because the position is increasing. So a little bit of a different direction than we've gone before, but it's still the same idea. We're still doing our same translations. We can also be asked about other related topics. I'm going to bring the graph along for the ride here. How about when, for what values of t is v of t increasing? Remember, we've got position, so I'm going to do my v graph. Remember, this time I'm translating up. So when a function is increasing, decreasing, its antiderivative is concave up, concave down. So I'm looking for concave down right here from 0 to 4, concave up from 4 and beyond. So that means I've got decreasing and increasing here. I'm asking about v, so v of t is increasing when t is greater than or equal to 4. Just greater than, actually. And similarly, for what values of t is acceleration, a of t, let's say negative. So I want to know about a, positive and negative, but what I have is p, position. So the derivative of position is velocity, and the derivative again of that is acceleration. So if p is our original function, a is our second derivative, it's f double prime. So f double prime is positive, negative, when f is concave up, concave down. So just like we did in the previous one, only now it translates into plus and minus. Oops, I reversed that. A of t is negative when t is between 0 and 4 because position is concave down. The final type of problem that we can see involves two different graphs. So let's say this is our third problem. The graphs of the velocity of particles A and B are below. So here's velocity particle A, velocity particle B. At what times are the particles traveling in opposite directions? So direction, that's talking about velocity. What it means is it means when does velocity have opposite signs? Let's write that a little more neatly. When do their velocities have opposite signs? Well, I can see for particle A, we're going between 0 and 8. And I can see it's positive up until 4, then it's negative until 6, then it's positive again until 8. Whereas over here for particle B, it's negative up and if I overlap them, I'm looking for where their velocities have opposite signs. So here, the top one's negative, the bottom one's positive. Here, the top one's positive, the bottom one's negative. And there we go. Our answer is when t is between 0 and 2, or t is between 4 and 6, because that's when their velocities have opposite signs. This concludes PVA 1 notes.